Hello, my name's Chris Kurzik, and I'm the Principal Engineer at Athabasca Engineering Solutions, AES for short. And what does AES do? Well, first of all, we provide third-party value evaluations. We provide training and certification. We provide equipment re-rating.
Welcome back to episode 5 for the MDMT subjects, and we're at the third and final slide of our review of Section 8 Division 1. And we're going to start off with the exemption curves for welding. We're going to talk about post-weld heat reduction for MDMT in more detail. And then we'll talk about hydrotesting and the MDMT. And that's important as well, and for safety. And finally, I'll talk about high alloy non-ferrous materials. We're going to begin with impact testing of welding procedures as described in UG 67. So general requirements. Check for exemptions, first of all, in UG 20F, UCS 66 and 68. These were described in the part 1 and 2 videos. Then they say if impact tests are required, then you follow the UG 84, which is the impact testing requirements. And the tests are required in the weld metal and the heat affected zone. Testing it must be done per the stamp nameplate, or you can use the exceptions listed in UCS 66B and UCS 68C. Two types of welding procedures out there. There's called welds with filler metals, and which is shown typically here, right there. Those are the most common. And then there's another type of one is called welds without fusion metals, and typically that would be like aluminum. And so it's also called fusion welding or autogenous welding. Excuse me. And those are the two processes which are described. So when you go to UG 67, it's broke very distinctly into those two classification groups. Now, impact testing of weld procedures to UG 67A 1 and 2. It's describing welds with filler metals that require impact testing when any of the following apply. Okay, so the first one is basically if it's required by the rules of this division, or I simply say the code. And when the weld pass thickness of any individual pass exceeds 13 millimeters, which is, if you want to be really exact, it's half an inch, okay? And the MDMT must be colder than 70 Fahrenheit or 21 degrees centigrade. Then you go to part 3 of UG 67A, and this is sort of a corollary of that. It says, weld filler metals are now exempt, not required, but exempt from impact testing by the following conditions. Okay, so if the base metals and impact testing is exempt by UG 66G, so they're really trying to make sure that all their bases are covered. There's a little bit of overlap. And so the next one is UCS 66, C and D. If you're following those type of curves, so as recall from the earlier videos, type D would be like a normalized 5/16 grade 70 material, low impact materials. If you're required, if your MDMT is between minus 48 degrees centigrade and minus 29, then you can be exempt from that if you're using the C&D curves and you're operating in that range. Impact testing of weld procedures will continue with 67A3. This is welds with filler metals that are exempt from impact testing. And so a PQR with impact testing is like, that's the weld procedure with impact testing is not required if the following. So if the maximum production weld pass is less than 6 millimeter or a quarter inch in thickness. And the second criterion is if each weld or a lot or combination thereof follows an SFA classification, and it's been impact tested that way. Impact testing of welding procedures UG 67A4. Welds with filler metals are exempt from impact testing if the following: when the joining base metals are exempt from impact testing by UCS 66G, and the MDMT is colder than minus 48 centigrade or minus 55. Of welding procedures per UG 67B. This is with regards to welds without filler metals. Okay, and they say weld impact testing is required if any of the following. So once again, if it's required by the rules of this division or by the code, and if with the weld thickness is greater than a half an inch or 13 millimeters, regardless of the MDMT, it needs to get done. If the weld thickness, here's a second case, if a weld thickness is greater than 5/16 of an inch and the MDMT is less than 10 degrees centigrade, then impact tests are required. And lastly, the joining base metals are exempt from impact tested by UCS 66G, and if the MDMT is colder than 48 centigrade. To weld joints, post-weld heat treating, and allowable stresses as described in the new section called UCS 68A. And UCS 68 provides supplemental design rules for carbon and low alloy steels with regards to weld joint categories as described in Section 8 Division 1, the joint types, and the post-weld heat treatment requirements and allowable stress values. So the first part is, this is your typical weld joint, and it says that the welded joint shall comply with UW-2B. That's a criterion if the MDMT is colder than minus 48 degrees centigrade or minus 55 Fahrenheit, unless the coincident temperature defined by UCS 66 is less than 0.35. And as you recall from the previous video, that's sort of the criterion where you can get a lot more credit when your stresses are below a certain value. And we'll see in later in videos how in Division 2 how the CR ratio can vary with the design standards used. So welded joints, post-weld heat treating, allowable stresses. So welded joints shall be post-weld heat treated to UW40 when required by code. And if the MDMT is less than 48 degrees centigrade and the coincident ratio is greater than 0.35, then post-weld heat treating is required, except for the following criteria. So vessels must be, or vessel parts must be made of P1 materials that are impact tested at less than the MDMT. That the average for the base metal and weldments shall be equal to or greater than 34 joules, which I'm an imperial person, so 25 foot-pounds, instead of the values shown in UG 84. So they've amended the standard requirements in UG 84. Okay. We're going to move on to post-weld heat treat for MDMT reduction without impact testing. A lot of standard calculation like compress, they always mention this requirement, or it's available. And basically the post-weld heat treatment improves the heat affected zone in the HAZ and grain structure and increases the weld metal toughness because it removes the stresses from the grains. And it's interesting, in some future videos we've done a lot of work with crack growth and so on, and you can see from those calculations how much an effect post-weld heat treat can be on improving toughness of a part and and improving the impact, the MDMT. And so this is if the entire vessel, it also reduces the the residual cold forming stresses so in the material. So that's like when something's been cast, or you have a welded assembly, and then the parts, they finish the welding's hot, and then it shrinks, and then it puts the stress into the part. And so this is a great way to remove that. So here's some thoughts. So they said, this is very important, post-weld heat treatment can reduce the MDMT. You can get a credit of 17 degrees centigrade reduction if post-weld heat treatment is not a code requirement. Okay, so if you add this as an extra requirement to get it more into MDMT without a code, then you're fine. Continue with post-weld heat treatment for MDMT reduction without impact testing, UCS 68D. So we've got the allowable stress values used for the MDMT, and you must use section 2 of the code, part D, subpart 1, table 3 for bolting. And the requirement stands that you need to use table 1A for other materials for temperatures of 38 degrees centigrade. Move on to hydrotesting. This is one of the most important parts in the code. It's with regards to making sure that you're not hydrotesting at a temperature below your MDMT. And of course, the implications of that, of going like hydrotesting below the MDMT temperatures, you could have a brittle failure of your vessel. And that can occur in the field or in the shop. So, and there's a part in the fitness for service where they actually do evaluations to make sure that they're not hydrotesting below that. So I spent a lot of time talking about it because it's that important, and I've seen problems like this where it's a safety issue about hydrotesting below the temperature. So this is what the code says. Okay. So, this is typical setup for hydrotesting here. So if I wrote it in terms of a formula. So your hydrotest temperature per UG99H must be the calculated MDMT, okay, and that's you have to do the entire vessel, all the components, and get the warmest one, right? And then you put a margin, and that margin must be 17 degrees centigrade. And they're saying that temperature, doesn't need to exceed 48 degrees centigrade. Now, that's by code. Some clients have very specific requirements, but this is the code. So you know, read the specs on this one. So pneumatic testing is found in UG 100C, and they don't have any limitations on the temperature. With the pneumatic one, they have this, maximum 38 degrees, and they say if you exceed it, they want you to, let it cool down to that temperatures. And there's some specific requirements for the upper limits. The pneumatic one, I have not found any specific requirements. So basically, it's the MDMT plus the margin, and that's all that's required. About Division 1, as opposed to Division 2, is they have, in addition to the UHA section, which I think is quite clear, but they have an addendum called JJ. It's like a non-mandatory section, and it just sort of explains things a little better. The charts are actually fairly good to understand. So they've got 4 figures for the austenitic stainless steels and the different grades, like the 200s. And so, but it's like the austenitic group, okay? And so the first, so they what they do is they have the base metal in the HAZ, heat affected zone, and they group those up as one group, okay? And they have a set of procedures for those in terms of a chart. And they also have a welding procedure qualification and a toughness requirement. So you can see how procedure, -2 is a separate chart. And then another chart that's separate is the consumable, because it's important to get the consumables right. Like, it has to have the correct, what they refer to as the ferrite number, and there's specific requirements for the ferrite numbers, and that's the big thing with stainless steel. So they have a separate section of that, and I think it's sort of tuned to the manufacturer so that they are meeting those requirements. And there's other standards, right, at SFA, and other ones that sort of confirm that. And then, of course, there's the production toughness requirements, which is part 4 for the stainless steel. In the 5th table, basically they just throw in all the other stainless steels. I kind of wish they'd organize this a bit better, but it's figure 5. It's called the austenitic ferritic duplex ferritic chromium and martensitic stainless steels. And in this section, they sort of throw everything into this one. But it's a pretty good chart. So let's work on another one here. It's called the AUH 51, and there's the figure which you mentioned about. This is the one for austenitic stainless steel. So it's JJ 1.2-1, and basically the first test for exemptions is the thickness less than 2.5 millimeters or 0.1 inches basically, and then it's impact temperature exempt. Okay, and this is just pulled from the graph. The next thing they'll ask you, is it UHA 51G exempt? So this has to do with a low stress, the coincident ratio or the low stress ratio. The stress, if it's a low stress part, then we don't have to, we can go with lower impact temperatures, okay? So, and of course, this is familiar. This is from earlier videos where we looked at the alloy steels, but in this case, we take the ratio of less than 0.35, and it's supposed to be based, that stress relationship is supposed to be based on the temperature to the allowable stress. And what's interesting about this, that is it applies also to welding. The quiz here, there's of figure JJ 1.2-1, where there's a section called 51D. It's about the casting, And so there's just a very simple test right off the bat. It says, well, you know, if you're warmer than minus 20 Fahrenheit, minus 29 centigrade, then you don't have to worry about impact testing. So it's a very, very general thing, because I go through all the steps. If you're not really using it at cold temperatures, maybe you're using the stainless steel for corrosion protection, not for cryogenic reasons. And so that rule applies to your chromium nickel stainless steel, your Series 300 and your Series 200. And Series 200 has the manganese in the product. So let me skip on to another part of this chart. It's basically if they ask you a question, okay, has it been thermally treated? Which means a solution treated for stainless steel, and there's some definitions for that, and that's to make sure that the grains are nice and even. If that occurs, and you got a credit to minus 20 degrees Fahrenheit, and that applies to the different types of austenitic stainless steels. Steps here. So we got austenitic stainless steel, carbon content again. So there's a UNA rule called D1, but one is for the austenitic one, and the other two is for the ferritic one, and they have a carbon content. If you have a carbon content of less than 0.1 and minus 196 is your MDMT. And then there's another case where it's B, where you're the opposite. If you've got a higher carbon content, then you're basically looking at a higher MDMT. So the graph will show something like this, and basically you've got yes, you proceed that way if your carbon content is less than that, and no, you would go the other way. So let's go to the yes part. So the yes part, I've just basically superimposed that portion of the graph, and you follow the rules of 1BA. And basically, if you're warmer than this 196 centigrade, then you don't have to do impact testing. But if you've got very extremely low cryogenic services, they're recommending testing that. And if we continue, so we'll look at the bottom part here. So in this case, we've got a carbon content greater than 0.1. So then we look at the MDMT again. This is colder than minus 55. So that means, and we meet this criteria, means we don't have to impact test them. But if we go to yes, then we do have impact testing. UNF. If there's any requests for more details on the other materials in the future, in the high alloy section, please send me an email, and we can add some more discussions. But let's continue on to non-ferrous materials. I mean, that's like Hastelloy. I've worked a lot with Hastelloy in the past. But typically, how often are you going to use Hastelloy for cryogenic, like that kind of material for that particular purpose? But there's not a lot of guidance in here like you see with the stainless steel, the austenitic. So this falls under UNF 65 in Division 1. And basically this includes like aluminum alloys, which is a very common cryogenic application. And you're down to, you're basically, your minimum is 269. And they basically say impact tested if you get colder than that. And there's not much more to that. I mean, I think there's experience in engineering more involved with that. Again, copper, it's copper alloys, nickel alloys like Hastelloy, alloy 20, and all these things. Cast aluminum alloys, they're saying you got it's down to 198. Again, these are fairly commonly used for cryogenics. And then titanium, which I don't have any experience personally with, except for your golf club type stuff, with sports equipment. So titanium or zirconium and their alloys are down to minus 59. And that's basically it in a nutshell for Section 8 Division 1. I hope you thought this was interesting. I really look forward to your comments. It's always great to review this UNF, the MDMT. It seems that every year we see problems with a misinterpretation of the MDMT. And so that was what inspired us to do these videos.
I hope that you found this presentation useful and valuable to you. This was provided by Athabasca Engineering Solutions. We'd love to hear your feedback and your thoughts on further videos. And we'd love to hear from you. Maybe we can do some business. Please subscribe to our channel so you don't miss a thing. Take care for now.